Hello, everyone, and welcome to episode 4 of our NF Core training, Making Your Own NF Core Pipeline. In the last episode, we discussed how you could find already existing NF Core pipelines and download them. We explored how to run its demo pipeline and how you can use test profiles to test pipelines once you have downloaded them to make sure that they're working correctly. Now, in this section, as I said, we're going to learn how to make your own NF Core pipeline. And so our objectives for this session and the things you should be able to do by the end are you should be able to create a custom NF Core pipeline using the command line tool NF Core tools. You should be able to run a custom NF Core pipeline using a test profile you've created. And you should be able to explain the purpose and contents of NF Core modules. And finally, you should be able to add multiple modules to a custom NF Core pipeline. Now, to lower the difficulty barrier for NF Core pipeline development, NF Core has provided a pipeline template that adheres to all of the NF Core guidelines, as well as a command line tool that's within NF Core tools that allows users to create a custom pipeline using this NF Core base template. In this episode, we're going to create your own custom NF Core pipeline using this command line tool. So to start, let's create a directory for our new pipeline using the following commands. We're going to use makedir, mkdir, and we're going to name this directory my pipeline. Now if we do ls, we can see that that pipeline is there, and all of the directories from our previous episode are there as well. So now that we've made that directory, let's move into that directory using cd. So cd my pipeline. Oops, spelled it wrong twice. There we go. My pipeline. We've made the directory, we've moved to the directory, and we can use NF Core tools pipelines, which we've already used in the past. And we're going to use a different option this time. Instead of using list or pull, we are going to use create. So let's type in nf-core pipelines and then create. Now this command starts up NF Core's pipeline creation wizard is what they call it. And it's an interactive text user interface that allows us to set up the pipeline. As you can see here, there's some text about creating pipelines, but we're going to go ahead and click Let's Go. And this will take us to our choosing our pipeline type page. And so for this, we are going to select custom because we're making our own. So let's go ahead and click custom. It asks for a GitHub organization and a workflow name. We are going to just go ahead and call this my organization, because we don't have an organization we're associated with for this training, so we're just going to use a generic fill-in called my organization. If you had a GitHub repository for an organization you were working at, you would want to put that organization name here for that particular repository organization, but we're not going to do that here. We're just giving it a generic one because we are not going to interact with, I'm getting ahead of myself, but we're not going to interact with GitHub for this particular pipeline creation. We're just going to start by creating it. So now we need to give the pipeline a name, and I'm going to call it my pipeline. We've got for organization, again, my organization, and for workflow, we have my pipeline. In the description, we're going to put my first NF Core pipeline. This, of course, can vary by what you want to describe it as, but feel free to name it something else or follow along with what I am typing. And now for authors, I'm going to put my name. I always like to include my middle initial since that's associated with my publications. And there we go. We're going to click next. And this takes us to the template features page where you decide the features you're going to include in your custom pipeline. So there's a couple of features we're going to use first. So we're going to toggle off all features because we're not going to use all of these. And that toggles see how the green square is gone? If I were to click this again, the green squares would come back. That means that particular feature is on. But we are not going to use all features, so we're toggling this off by clicking this green square. We're going to toggle back on the features we do want to use by clicking on the squares. So first is we're going to add a configuration file, which is here. And there's got a little descriptor here and some help buttons as well, but this says the pipeline will include configuration profiles containing custom parameters required to run NF Core pipelines at different institutions. So we do want that. So we're toggling that on. We also want multi-QC, so use multi-QC. Multi-QC is a tool that takes a lot of different results from various QC programs and makes figures for you in an HTML file for those of you who aren't familiar with multi-QC. And so it says the pipeline will include the multi-QC module, which we're going to talk about more about modules in a bit, which generates an HTML report for quality control, as I just said. We are also going to use NF Core components, so we're going to click the square for that. And this says include all required files to use NF Core modules and sub-workflows. So this is what's going to set up our modules folder. Next, we need to use an NF schema. And schemas are for Nextflow plugins for the pipeline. Finally, there's two more. We're going to say add documentation, which pretty self-explanatory, adds documentation to the pipeline. And next we're going to do add testing profiles because we want to have a test profile so we can test that our custom pipeline is working as expected. And then it says add to default testing profiles. So that's all we're going to toggle on. And now we are going to, accidentally misclicked. Whoop. And now we are going to click continue. In the final details page, we're not going to bother with this. We're just going to keep this as the first version 1.0.0 dev and the path to the output of the directory where it will be created. We're just going to have it created here in the directory we made. So we're going to do that by specifying a period. And we're going to click finish. Notice here it says creating new pipeline, initializing local pipeline in Git repository. Like I said, we are not going to interact with GitHub or any repositories for this part of the pipeline creation. And it says pipeline created in my organization - my pipeline. So when you create a pipeline, it will put the organization name, a hyphen, and then whatever you named the pipeline. So we'll go ahead and click continue. And then finally it asks, after creating the pipeline template locally, we can create a GitHub repo and push the code to it. Do you want to create a GitHub repo? We are not going to do this for this. So we're just going to click finish without creating a repo. It does have instructions for what to do if you do want to make a GitHub repository. So first you need to create a new GitHub repo. You need to add the remote to your local repository, and then you need to push the code to that remote repository using git push. But again, we're not going to be using GitHub repos as part of this, as it is outside the scope of this lesson material. So let's go ahead and click close because we're done with the creation wizard and we're going to close it. And if we do ls, we can now see that there is a directory here that was created called my organization and -my pipeline. So let's go ahead and move into that folder, and we're going to do ls to see what we see. And there's a number of folders here, as well as a number of files. These folders' contents and these files here are what you need to create and run an NF Core pipeline. Like I said, this is a template that NF Core has set up so that you do not have to manually set up all of the necessary files yourself. We're not going to go through every single directory and every single file in that directory, but we are going to, as I said, create a custom pipeline, and we're going to go over the necessary files and directories for you to be able to do that successfully. So we're in the directory already, and we are going to use the Nextflow run command to test this pipeline. So we're going to go ahead and type in Nextflow run, and then we're going to do a dot because we're in the directory of this pipeline, so it will run it. We're going to give it a profile, which, as I said in the previous episode, I use Docker to run my Nextflow pipelines. And we are going to run the test profiles very similarly to how we did with the demo pipeline in the last episode. So we're going to type in test, and then we're going to specify the other necessary parameter for this pipeline, which is the output directory. So that is -- outdir as a default. and we're going to say results. So we've clicked enter, the pipeline is going to run, and notice it says downloading a plugin for a schema. And this should look familiar since we just ran the demo pipeline in the last episode. We have our input here that's included in the test profile. We have the outdir we specified. We have everything from the profile name and description to where the name of the trace file is. And then you have all of the other necessary directories that are listed for this particular run. So we've got a process going for multi-QC, and we're going to let that run. Now, as you can see, the pipeline has completed successfully. Here we see that the duration was 1 minute and 21 seconds, And this single process, which is multi-QC, because remember, in the template, we said we wanted to use multi-QC. That was included, and it ran successfully. Let's go ahead and do ls again. We can see that there is a results directory, and let's go ahead and enter that results directory. We'll use tree, and we're going to do results. And as you can see, here is the information from our pipeline. So the only step that ran was multi-QC, and the most relevant file to our output is the multi-QC report.html. We're not going to explore that because we're going to make changes to the pipeline and add more steps to it, but these are the files you would expect to see if the pipeline ran successfully, as it says here. To customize a pipeline and make ones ourselves, we have to add modules to our pipeline. As for what a module is, it's a Nextflow wrapper around a command line tool or script. And a wrapper is a computer science term for a program or function that calls another program or function. So in other words, a module contains a Nextflow script and a few other files we're going to discuss in a bit that is used to run the command line tool or script contained within that module. Modules are used as individual processes within a pipeline. So we talked about how processes are a critical part of workflows that are the part of workflows that do a task. So modules are processes that do a task within an NF Core pipeline. And it's important to note that NF Core modules contain either a single tool with one subcommand or one subcommand of a tool with multiple subcommands. So for example, the genome assembly tool shovel contains only one command, so there's only one shovel module. Conversely, the FASTA and FASTQ processing tool, seqtk, contains multiple subcommands, so there are multiple seqtk modules, one for each subcommand. And you can actually develop a module for a tool independently, and you can save a lot of time and effort by using existing NF Core modules instead. And there are thousands of those, which I'll show you in a second. Each NF Core module contains files with very strict guidelines for structuring content. And these guidelines expand the number of files from one Nextflow NF script to 5 mandatory files. So I'm going to open up a browser, and we're going to go to nf.core.re, so NF Core's website. And instead of going to pipeline, we need to go to resources and then modules. I'm going to show you the shovel module since that's one of the modules we're going to be using today. This is the NF Core module page. As I said, it lists how many modules there are. There's approximately 1,500 modules right now. And let's go ahead and click on shovel. This is very similar to the pipelines page in that it has the information you need for what the module does. But like I said, we're going to go to the GitHub repository first to just go through an example of what the files that NF Core requires are. And then we're going to go back to this page later and talk about this page more in depth for exploring modules. So let's click on this GitHub repo link. And so the main files that are going to be included are this environment YAML file, the main.nf file, the meta.yaml file, and then within tests, the key files for this are the main.nf.test and the main.nf.test snap. We're not going to discuss these particular config files here because they are specific to shovel. These files that I just told you about can be split into 3 main categories. The first is execution, and that includes the main.nf script and the environment.yaml file. The main.nf file is the main Nextflow script that defines the process executed by Nextflow. So if we clicked on main here, we would see that this is a process. So we talked about processes, like I said, in episode 2, and this is the structure of a process block that we discussed. So this main.nf script contains the process that will run within this module. If we go to shovel directory again and we click on the environment.yaml, this defines the conda environment, and it is loaded by the main.nf script. It specifies the software dependencies for the module when a pipeline run is executed with the conda profile, which I am not using conda. Like I said, I'm using Docker. And now the next main group these files for the wrapper and module can be divided into is the documentation subcategory, and that is the meta.yaml file. So the meta.yaml file documents the contents of the main.nf file, including things like its inputs and outputs. You can see the tools listed, some keywords associated with it, the input, which includes the description of the input, the fact that it's reads, it mentions the output and some logging and a lot of other things. So if we go back to the shovel directory, we're going to go into the test folder this time, and we're going to talk about the main.nf files here. So first, the main.nf.test file. This describes a unit test for the main.nf. So this is a test for the process. We're not going to go all the way through this file. Going through this is outside the scope of the episode. We're going to go back to test, and then here is this test.snap file. And it's a snapshot file that is generated by the nf test, so generated by this. And it is used to compare the output of one test run with another, which ensures reproducibility. Because if you'll remember from episode 1, one of the most advantageous things about NF Core is its emphasis on reproducibility, which is incredibly important for making sure your workflow works as expected. Now that we've gone through all that, we can talk about the state of our pipeline and how we want to change it. So currently, our pipeline that we've made consists of only one step, which is that it runs multi-QC. And if we want to add a new step to that pipeline, we need to add a new module. And there's a collection of NF Core modules that are stored in a central community repository that can be used by anyone. And there are two main ways that you can find NF Core modules to add to your pipeline. You can manually search the modules page on the NF Core website, like I just showed you, or you can use the NF Core tools on the command line, much like you used the NF Core tools on the command line to look for pipelines that are available. So we're going to start with online. We're going to go back to NF Core's website, nf-core.re. Oops, typed that wrong. There we go. So we're going to go back to shovel as an example. So we're going to type in shovel in search. We're going to click on shovel. The useful things on this page are the description, the input, and the output. The description has a description of the module. So shovel assembles bacterial isolate genomes from Illumina paired end reads. You're going to have your inputs, which is a list and description of the module's inputs. The inputs for shovel are a meta map, which is a groovy map containing the sample information, such as the sample name associated with that sample. And then we have the reads, which are a required input. And this is a list of input of paired end FASTQ files. So this would be the reads that you would reference in a sample sheet while running the pipeline. Now, as for the outputs, this is a list and the description of a module's outputs. For shovel, that includes a contigs file, a file called corrections, the log associated with the shovel run, raw contigs, and a GFA file, which is an assembly graph that's produced during the run. And all NF Core modules have this. All NF Core modules have a versions output. That's a YAML file that contains the software versions of the software that the module runs. That is the important stuff you need to know about the modules page online. And same with the pipelines. You can go to Slack and ask a question about a module, or you can open an issue on GitHub if you're having a problem with the module. So I'm going to give you a challenge here. After I read the challenge, you can hit pause and go try and complete the challenge. And once you've completed it, you can press play again and see if you got the answer right. But for this challenge, I'm going to ask, what are the names of the inputs and outputs of the SAMTools stats module? So go ahead and click pause here and go find that module and find what its inputs and outputs are. So now that we're back, I'll show you the answer to the challenge. So we need to go to modules, and then we're going to go type in SAMTools, which you'll notice brings up several results. And we care about stats, and we need to do an underscore for that. I believe if you just did a space, nope, that does not work. So you need to do underscore for that. So we're going to click on SAMTools stats, and SAMTools stats produces comprehensive statistics from SAM, BAM, or CRAM files. So we've clicked on that, and the inputs to SAMTools stats are a meta map, an input file, and an input index file, as well as another meta map and a FASTA file. And some of these are optional. Now for the outputs, we have the stats, which includes a meta map and the stats file, as well as a versions file, which contains the software versions. So that was the answer to that challenge. Now that we finished the challenge, we're going to move on to how you can find modules on the command line. So we're going to go back to my terminal. This is a little messy, so I'm going to go ahead and clear my terminal so we have a nice clean slate. To look for modules on the command line, we're going to once again use the nfcore tools tool on the command line. So we're going to type in nfcore, and instead of pipelines, because we're not looking at pipelines, we're looking at modules, we're going to type in modules, and then we're going to do list, very similar to how we did pipelines list, and we're going to do remote as the next option. Now what this did was list every single module available in nfcore. As you can see, this list is quite long. In fact, if I were to scroll all the way up, I would not see the top of the list because this is 1,500 lines. But we can do something if we want to get a particular tool, like let's say we were interested in every single SAMTools subcommand. We could do nfcore modules list remote, and then we can use a pipe and the command grep, which grabs certain words, and type in SAMTools and then hit enter. So what this did was it showed us every single nfcore module that contains a SAMTools subcommand. That's one way you can look for modules. So now that we have looked at how we can find modules both online and through the command line, we're going to install our first nfcore module. Now to install an nfcore module, we use the nfcore modules command with the install option. We're going to continue using the shovel assembler as our example. And before installing the shovel module, you need to make sure that you're in the directory where the pipeline directory is. So we're just going to do that real quick by doing pwd for present working directory. And if we do ls, we can see all of those files that the pipeline creation wizard made for us. And so to, again, install a module, we're going to do nf-core modules, and then install. And because we're going to install shovel, we need to type in shovel. And we're going to hit enter. Notice how nfcore is now installing. We're going to wait for that to run. All right, and now we have some output that says info, installing shovel, and then it says info, using the following statement to include, or excuse me, use the following statement to include this module. Include shovel from ... modules, nfcore shovel main. Once the module has finished installing, we can use the modules nfcore command with the list local options to see what modules have been downloaded for the pipeline. So remember in the previous command, we used remote, which showed us all remotely available pipelines. And if we use local instead, it will show us what's installed. So we're going to type in local this time instead of remote. So it says here, info, repository type pipeline, and then it says modules installed in our present working directory. The modules we have installed are MultiQC, which was included when we created the pipeline. It has the version, SHA, so the digest associated with it, the message, and the date. Now, for Shovel, we have the repository, again, the SHA, and any messages or dates associated with that. Now that we can see that this module is installed, what we're going to do next is we're going to take a look at the directory where modules are found, because here it says this is the directory where that module can be found. So if we do ls, we see that there is a directory called modules. So we're going to move into that directory. If we do ls again, we see that there's NF core modules. So we have no local modules that we've made. If we had custom modules that we made, they would go in a different folder in this directory, but we're going to change into the NF core directory. We're going to do ls again, and now you can see that the directories for each tool, each module we have installed. So we have MultiQC and Shovel. We're going to go into the Shovel directory, do ls again, and as you can see, we have our environment, main, and meta files that we talked about, as well as the files associated with tests. So the module is now installed in the local directory of the pipeline. Now, this does not mean that the module has been added to the pipeline, which we'll talk about in a second. It's solely downloaded. So we're going to go ahead and download the module for seqtk trim, which is the other step of the pipeline we're working on that we're going to run. So let's go all the way back up to the main directory of the pipeline, which is here. And we're going to install seqtk. So to do that, we need to do nf-core, followed by modules, followed by install, and then the name of the tool, which is seqtk trim. And because this is a submodule, the tool's name will be listed here, and then there will be a / and the name of the particular subcommand. For those of you who are not familiar with this tool, seqtk trims adapters and low-quality bases from sequencing reads. And in the pipeline we're creating in this lesson, this is the program that we're going to use to clean our reads prior to assembly with the tool Shovel. So let's go ahead and click enter. It's installing, and you can see a similar output in it, that it says installing seqtk trim. Use the following statement to include this module, and then it has the statement you need to include. As I said, this module has been downloaded, both seqtk and Shovel, but they have not been added to our pipeline. They're downloaded only. Several lines of code need to be added to the workflow file for the module to be included. So remember, processes are a part of a workflow that run specific tools and do specific tasks. We have downloaded them, but we actually need to add these statements to our workflow file for it to actually run when we execute the workflow. So we need to go to the workflows directory. So we're going to change directories into workflows. Let's take a look at what's in this directory using ls. There is a Nextflow script here called mypipeline. Now, I'm not going to open this with a text editor like Nano. I'm actually going to go to my file explorer to open this file. So we're going to go to my pipeline, my organization, my pipeline, and then we are going to go to workflows and click on mypipeline.nf. And this opens this file on top of our current existing terminal. So I'm going to move this down a little bit. This is a workflow script. So notice here that there's the word workflow, and it's called mypipeline, and then it has the curly brackets that contain a workflow in all of its steps. Notice there are several sections. We have the import modules, sub workflows, and functions section. We have our run main workflow section, which contains the workflow block. If we scroll down, we see all the way that there's a part where it says the end, and that is the end of the workflow file. We need to add an include statement for the module, and the include statement should contain the name of the module in curly brackets, which is also the name of the process that uses the module, followed by the from statement and the path to that module's main.nf file. As the output of the nfcore install modules option says, you need to use include seektktrim from the path to that main.nf script for that module. So we need to copy this statement and add it to our import modules, subworkflows, and functions block. So let's do that. And these can go in any order. Actually, I am going to move this to beneath multi-QC. The include statements don't need to be in any particular order. We've added seektk now via this include statement. And now we're going to include shovel. So we're going to scroll all the way back up. We're going to copy include shovel from modules nfcore shovel main. We're going to copy that. We're going to hit enter here. We're going to paste this. Now you'll notice that these from statements are all in line with each other. So I'm actually going to add some spaces so that they're all in line with one another. This is an aesthetic choice. I'm going to do that. Oh, I accidentally clicked insert. There we go. And now they are all in line with one another. And I'm going to go ahead and save. To save, I'm going to do Control S. So now those include statements are within our mypipeline.nf script. And this is not the only thing we need to do, because we have told Nextflow that these are the modules we want to include, but we still need to put those modules within the mypipeline workflow so that they will run. So we need to add our process to within the curly brackets of the workflow block of mypipeline. And again, this can be found in the run main workflow section. And we're going to do this in front of software versions to YAML or YAML. And we're going to type in seektk_trim, and then we're going to add two parentheses, an open and a closed parenthesis. So this is the process here, which is again included here. So this is the process name, and we're going to include it by putting it here and adding an open and closed parentheses. Now that means the process is going to be included, but it still needs its inputs because every process has an input and an output. To add seektk's trim inputs to the process, we can either find the module's inputs and outputs on its web page, or you can use the nfcore modules command with the info option. So let's go ahead and do that. We're going to temporarily hide this so it's not cluttering things. We're going to scroll all the way back down, and we're going to type in nf-core modules, and we're using the seektk trim module. So seektk /trim. And we're going to type in info and then hit enter. Oh, I accidentally did this in reverse. It should be info and then seektk trim. There we go. Now we have this nice pretty output here where it lists the module, which is seektk trim, where it's installed at. So this is the full path to where it's installed. It has its description, and then we have a table of its inputs and outputs. For our input, the main thing we need to list is the input fastq files. And just as a note, you can also look in a module's main.nf script or its meta.yaml file for its inputs and outputs. But one of the simplest ways is to use the info option or to go online to nfcore's website and to look at the inputs and outputs. So the seektk trim process only requires one input channel, which should contain paired end fastq files and their sample information, which is the meta information. And this channel actually already exists in the mypipeline.nf script. So let's move the terminal back down. And if you look here, we see that there is a channel called ch_sample sheet, which is here. So we're going to take ch_sample sheet and we're going to add it to the seektk trim process, which will tell Nextflow, use this sample sheet as an input to this process. So let's go ahead and type ch underscore sample sheet. We're going to save again by doing Control S. And we're going to hit pause here, and I'm going to offer another challenge. This is our second challenge for this lesson. So you can hit pause after I describe the challenge, and then you can go try the challenge yourself, or you can hit play again to get the answer. What 3 lines of code would you need to 1. Install the FastQC module, 2. Include the FastQC module in your workflow, and then 3. Call the FastQC module in your workflow using reads underscore ch as an input. So go ahead and hit pause here. Now I'm going to open a new file to type in the answer to this challenge. So I'm going to go to File and then New File. I'm going to say Text File. And so to install the FastQC module, we would use the nf-core command with modules install FastQC. And then to include this in our workflow, we would need to use an include statement. Include curly bracket space FastQC. We would have another curly bracket, and then we would say from, and we're going to give it the path, which starts with a single quotation mark, / modules /nf-core /fastqc /main, and then finally a closed single quotation. Now, as for the final question, to include this process within our workflow block, we would need to do FastQC and open parentheses, and then I said I wanted the reads channel to be named reads underscore ch, and this is where we would add that. We would say reads underscore ch. And those are the answers to that solution. If you want to, you can try installing this yourself and seeing if you get it correct. But these are the answers you need to be able to add FastQC, which we will not be adding this to our pipeline. And this is an important way to test your knowledge and see where you're at in learning the material. So I'm going to go ahead and close this file. I'm not going to save it. So we've added SeqTK, and now we are going to test our custom pipeline with a custom test profile. So to do that, we need to move to the conf, the conf directory, which is where config files are stored. So I'm going to clear my terminal again because it's a little messy, and I'm going to close the my.nf pipeline. We'll open it again in a bit. So let's go ahead, clear the terminal. And we're going to go into the conf directory, the config directory. Let's see where we are. Oh, we're still in the workflow directory, so let's move up. Yes, and now we're going to go to the config directory, so conf. So cd conf. Let's take a look what's in here using ls. We have our base config, we have a modules config, a test config, which we have already run, and then a test full. So we're going to make a new config file called demo, and we're going to do this by copying the test config. So let's do cp, the test config file, and then we're going to name it a new file demo.config. Make sure I spelled that correctly and then hit enter. So now we have a file called demo.config here. And we need to make a couple of changes to this file. So let's open it up. I'm going to click on demo. And this is the same as the test config because we just copied it and renamed it. But like I said, we need to make a few changes. So it says define input files and everything required to run a fast and simple pipeline test. And it says use as follows, which we have done in the past. So this is going to stay the same, except instead we're going to change anywhere it says test to demo. So we need to change test to demo here. And then we need to change how this runs. So notice here it says the input is a sample sheet for viral recon that can be found in this particular repository. But we are going to use a different test data set because the programs we're using, or rather the program that we're using to do assembly, uses paired end Illumina files, and this sample sheet includes single end Illumina files in it. So we're going to use a different repo for this. We're going to backspace that. And this particular sample sheet that we're going to be used can be found in a publicly available GitHub directory. So I'm going to type this in here. So https://raw.github wslh-bio/main/sample sheet/test_full.csv. Now, what the heck is this sample sheet that's included from adding this link? Let's go ahead and copy this. We'll make sure that it works correctly. We'll go back to Google Chrome and hit enter for this. Oh, I see what I did wrong here. There is one error. This should be sample sheets, not sample sheet. So that is my mistake. And now that I've corrected it, we see here that this is a sample sheet. This is a sample sheet associated with Spriggan, which is a bacterial genome assembly and QC pipeline that we made here at the Wisconsin State Lab of Hygiene. So I'm just borrowing this sample sheet for our demo config file. So we have our samples 1 through 3 listed here, the forward read, and then the reverse read. So we're going to copy this. I'm going to go ahead and go back to the terminal. I'm going to backspace this and just copy and paste it directly. And now we have the sample sheet that we're going to use as input to this pipeline. The other thing we need to get rid of is params.pipeline test data base path, because we're not using this. We're giving it the full input directly. So we don't need this and can get rid of it. So the other changes we want to make are to correct the profile name and description. So we're going to change test to demo test profile, and then we're going to change profile description so it says demo test dataset to check pipeline function. These are just to make this unique compared to the other config profile. And one other thing we need to change that I did not mention is that we want to change defines input files and everything required to run a fast and simple pipeline test to, we want to change it to defines input files and everything required to run a demo pipeline test. So we're gonna get rid of this and say run a demo pipeline test. And now we can save this, and we have our custom demo config now. So now that we've created our demo config file, we need to tell Nextflow to include it as a profile. So to do this, we need to go to the Nextflow config file here and click on that. And then within the profiles block, which is found within curly brackets, we're going to scroll all the way down until we see the other profiles, test and test full. So we're going to copy the test full line. We're going to paste it, and then we're going to add the name of our profile, which in this case is demo. And then it says include config. And instead of test full config here, we're going to type the name of our demo config file, which is demo.config. And for aesthetic's sake, I'm going to add a bunch of spaces so that these are all aligned with one another. So let's go ahead and save. And now Nextflow will recognize that this config file we have is for a profile, a custom profile we made called demo. So we can test this now. And to test this, we can go to the main directory of our pipeline, which we are already in. If we do pwd, we see here that we are within the my organization, my pipeline directory. And we're going to do the Nextflow run command. So Nextflow run dot, because we're already in the pipelines directory. We're going to do -profile, And our profile is demo, and I'm using Docker, so I'm going to do comma Docker. And then we need to give it an out directory, which in this case is --outdir. And I'm going to name it demo_results. So let's go ahead and run this and see what happens. So you can see here that the pipeline is staging the foreign files, so the files from the test data set that we added to the demo profile. It has successfully finished multi-QC, and it's going to run seekdk trim next. Pipeline has completed successfully. That took 3 minutes and 42 seconds. And if we look in the results directory, which was demo_results, we'll see that there's output for 2 processes there this time, which were processed for 3 samples, which was our data set that we included in the testful CSV from Spriggan. So we're going to do tree and then demo results and hit enter. And this is the directory structure for the output directory, where we have all of the outputs for the multi-QC process that ran and all of the seekdk outputs for the trim module that ran. So we have the sample results named this for every single sample, which includes read 1 and read 2. And then we of course have our pipeline inflow, which has everything on execution, the parameters, and the versions. So for this next part of the episode, I've gone ahead and cleaned up my terminal and closed some documents so that the space is less cluttered for what we're working on. We've added seekdk, and now we are going to add shovel to our pipeline. And we actually need to edit part of the shovel module before we actually add it to the workflow because of some behavior it has by default. So remember, the Nextflow scripts for each module can be found within the modules subfolder. So if we do a quick PWD, you can see that we're still in the My Pipeline directory. Let's go ahead and change into the modules directory. And as you can see here, we have nfcore, and then we're going to change to shovel. If we do ls here, we see main.nf. I'm going to open it up in my UI here to edit it. So I'm going to close this, and then I'm going to open this and go to shovel and then click main.nf. And I'm going to move my terminal out of the way so it's easier to see. By default, shovel will actually overwrite files it's processing because it does not make each file name unique. So if you were using the nfcore module for shovel to assemble one sample and one sample only, that would be fine. But because of its default behavior, it will actually not give unique names to these files. And that's a problem because we're processing multiple samples. So to do this, we're going to change this path for each of the output files, as well as edit the actual script block to accommodate for that. And the thing we are going to add to each path is the meta ID. So the input to shovel is path to reads that you're giving it, which in our case, it's the reads that have been processed by seekdk. And this val meta here, which the meta.id contained within this part of the tuple is essentially the sample name. So we can go ahead and using a $sign and curly brackets, excuse me, those are parentheses. Let's do curly brackets here. We can type meta.id, and we're going to add a period here. So now that we've done this, we've told Nextflow, give the path, the output path, the file name for it, give it meta.ie meta.id, and it will include the sample name as part of the output name for that particular file. And we can do this for every single output file of the shovel module, and it will give them unique ID names so that they won't get overwritten. So I'm going to copy this so that I don't have to keep typing it over and over. And I'm going to put it in front of every single output file name in the output block. So now all of these files will have unique names and they won't get overridden. The only one we don't need to do this for is the versions.yml file. That is going to be the same. Now let's go ahead, for the sake of aesthetics, just put a couple of spaces here so all of the files are lined up with one another. Now, we've told the module that in the output block, expect these files with these meta IDs in them. However, the output is still of Shovel is still going to be the contigs file that doesn't have a unique name. So we need to add some bash to the process to move the standard default output files to this name. And to do this, remember the name is, so this particular variable for this one is contigs.fa, and we're going to say move contigs.fa to meta.id.contigs.fid, or excuse me, .fa. And we're going to do that for every single one of these output files. So move shovel.corrections to, I'm going to again copy to save time and to not do propagating errors, meta.id.shovel.corrections. And then we're going to move shovel.log to meta.id.shovel.log. Now, by default, we would expect spades to be in this file output. So we're going to say move spades .fasta to meta ID. I'm just going to copy this. .spades.fasta. And then finally, by default, it does a GFA file. So we're going to say move contigs.gfa to, again, meta id.contigs.gfa. So I've gone ahead and cleared my terminal and closed files to decrease clutter, but let's go ahead and run the pipeline now that we've added Shovel to it. So to do this, we're going to use the same command we used previously, where we do nextflow run, and then period because we're in the directory of the pipeline. I didn't mention this before, but I should mention it now. You could also do main.nf or /main.nf to run the pipeline, since you're in the directory where the main.nf script is, but I always just use period because it saves time, and Nextflow will look for the main.nf file in that directory for the pipeline you are running. Next, we need to do profile, and we're going to specify demo, since we're still using the demo profile, and Docker because I'm using Docker, and then we're going to add --outdir, and we're going to use the same output folder, which is _demo results. And then we're going to use the resume option because we don't have to repeat everything that's already been done. And we're going to click enter. And now this will set up the pipeline to run again. And we won't have to repeat the seek_tk steps since they're already finished, which will save us some time. Now, I actually had to rerun the pipeline because part of it crashed, and I didn't want to actually go through the whole process of debugging that in the middle of the webinar because it's not the focus of the webinar. So you'll notice that this says cached here, but the pipeline has completed successfully. And if we go into our demo results, we should now see that there's the folder with all of the Shovel results there. So we'll also do that on the command line. We'll go to demo results, Shovel. And as you can see, we have each of the individual output files named for their sample. Because if we hadn't made those changes to the Shovel module previously, we would just have one set of each of these files for only the final sample that was processed, which we didn't want. We want these files for every single sample that's being processed by Shovel. So Shovel has been added. SeekTK has been added. We now have our 3-step pipeline that we were setting out to make at the beginning of this episode and is the kind of final fruition of this webinar series. But there's one last thing we need to do prior to closing this episode out, and that has to do with the process that was already present in our workflow file. So I'm going to close this to save some space, and I'm going to go ahead and go to workflow and then mypipeline.nf, and the particular process that I am referring to, minimize the terminal here. The particular process that I'm referring to here is the software versions to YML process. What this process does is it takes the version output from each module and collates them so that they end up in this MyPipeline software MQC versions.yml file, so that the multi-QC HTML report that you get at the end of the pipeline has the versions of each software associated with it. And it does this via the CH versions channel. And we need to add each version's output from each module to the CH versions channel. And we do this via the mix and first operators, which are Nextflow operators. The mix operator emits the items from 2 or more source channels into a single output channel. So you can put the outputs of multiple channels into one channel, and that's why it's called mixing them. And then the first operator emits the first item in a channel. Now, why would we want that? Well, each process that we have in our demo profile will be run on multiple samples. So there will be multiples of the versions output for each process. And we only need the first one. We don't need all of those. We don't need all of those repeats. So after SeekTK trim, we need to redefine CH versions. And we're going to set that equal to CH versions dot mix. So that's the mix operator. And the way the mix operator works is you place it after your existing channel that you are going to mix other channels into. So we have ch.versions mix, and then the channel we are going to add to ch versions, the channel we're going to mix it with, is SeekTK trim, because that's our process, and the output, so out.out versions. So let's go to that module, down to SeekTK and then main.nf. This is the versions output I'm talking about. So each module has this. So we just need to put the process name, SeekTK trim, .out.versions here. And because we only need one copy of it, we're going to add the first operator. So .first, and then close parentheses and open parentheses. And now the CH versions channel has this output added to it. And we're going to do the same thing after the shovel process. We're going to copy that for ease of not having to repeat a bunch. And instead of instead of SeekTK trim, we're going to add shovel here. And now the versions channel will have the versions output of shovel, the one copy of it, mixed into the channel. And then this final version of CH versions will get passed to software versions to YAML, and that will end up in the multi-QC report. So let's go ahead and save this, and we will run our pipeline again. Now we need to move back up. Let's actually just go ahead and move this all the way up. We need to be in the main directory, and we're going to do Nextflow run period dash profile demo comma docker dash dash outdir demo results underscore results, and then dash resume. And this is the same command we ran last time. The only difference is that we have added those mixing statements into the workflow script, and we're going to see the results of that once the pipeline has run. It should go pretty fast because we're not redoing any processes. We're just taking the output of processes that have already been finished and passing them to another process. And notice it says multi-QC is running here and the pipeline completed successfully. It was very fast. So first things first, let's go ahead and open the YAML file. That's the output. So let's go to, nope, not results. That was a previous. We're going to go to demo results. And then we are going to go to pipeline info. I'm going to move this so we can see this a bit better. And here we have my pipeline software MQC versions.yml. And now we have seqtk, shovel, and the shovel module listed here. So these are their versions. And these got passed to the multi-QC file. So let's go ahead and close this. We don't need it anymore. We can also close the workflow file. And let's open up the folder to the multi-QC report. And then I'm going to open this using a browser, Chrome. And if you look right here, we have both the seqtk and shovel versions in the multi-QC file. Now, if we had given other outputs of, like, say, QC programs like FastQC or QUAST, which are certainly steps that would be reasonable to add to this pipeline if we were going to add more, those outputs would be passed to here via the multi-QC process in a similar way to how we mixed all of the different channels together for the versions output. But that's beyond the scope of this particular episode and webinar series. But just for now, know that when you actually do this step to mix the versions and pass it to the collation process, they will end up here in the multi-QC file, which is best practice. You want to know which versions of particular programs are running in your pipeline. So we've done every step we need to do to get our pipeline running and to add the versions to it. We could do some nice little cleanup stuff to make things a little bit more readable. So let's go back to mypipeline.nf. One thing we didn't do is we didn't add descriptors to our workflow, like this one here for the software versions to YAML process. It actually has collate and save software versions. So let's copy this, and in front of seqtk trim, we're going to add that, and we're going to delete its description, and we're going to say trim reads with seqtk. And then let's copy this again, and in front of shovel, we'll say assemble trimmed reads with shovel. And now we have some nice descriptors here for our pipeline. This means that people who read your pipeline will be able to know what that step does. And if we wanted to make things even more readable, when it comes to this channel underscore versions mixing, what we could do is we could set the output of seqtk versions to a variable. So we could say ch seqtk versions, and that would be seqtk trim out versions. And we could even just move this down. And then we could put ch seqtk versions here. And that way it's a little bit more readable, where we know that this is the seqtk versions output in a new variable, and we have put that here. And we can do the same with shovel, where we say ch shovel versions, and then we would do shovel.out.versions. And we could put ch shovel versions here .first, and that would just make things a little bit more readable for anyone else working on these scripts. It's really up to user preference. I do prefer to make my pipelines in this way, but if you find it redundant to make these variables with the channels, the output of particular processes in them, what's emitted, you could leave this step out. Again, it's very up to user preference. So with that being said, if you've completed this webinar, congratulations. You've made your first Nextflow pipeline using the NF Core framework. There are certainly other steps you could add to this pipeline if you wanted to branch off and, like I said, do things like FastQC or QoST so that you could get the quality associated with your reads as well as the quality associated with your assemblies. You could do more with your assemblies after the fact. If you're like me and you work with pathogens that are important in clinical settings and you're working with bacterial data, you could add in a step to do something like antimicrobial resistance gene detection. There's lots of things you could do to add on and branch out on this pipeline. But I also encourage you to go to NF Core's website and explore what pipelines are there, because there's some very good pipelines on the NF Core website that could already do what you're looking for. But I really hope this was helpful to you. We're going to be doing more webinars in the future with content expanding upon this. So thank you so much for your time, and I hope you found this to be a useful webinar.